space exploration. So I really wanted to incorporate some of that. My personal background is kind of in the commercialization of space a little bit more, so I've worked with a couple companies that are taking space to the commercial aspect. So I wanted to kind of split the presentation into two, and as I was talking through it, the commercialization part got way too long in addition to the exploration part. So I'm going to do the exploration part probably in a couple weeks. We're really just going to focus on commercialization yet. Okay, this is not showing it. So this happened last time too. Any shot I could send this to you?
Yeah, sure.
And then have it on your.
Yeah. Marcy, can you pass me my laptop?
So I've done work with. So last summer I was working for a company called Virgin Galactic. Anybody know who they are? Barshin was Virgin Galactic. So there's a guy named Richard Branson. He's a really, really rich guy that just kind of hangs out on an island and runs about 100 different companies. But he decided to fund one of these space companies to kind of get regular people to a point where they can just pay to go into space for themselves and kind of do it as this nice little joyride type adventure for them. So I got to kind of see what the industry is like and do a lot of work to. Oh, where did it turn off? So I got to figure out kind of what's going on in this commercial industry, and there's a whole bunch of really cool stuff. And this year specifically, 2019, has so much significance for what's happening in the space industry right now, for many, many different reasons. But one, who knows what's so special about July 20th, 2019? Anybody? How about July 20th, 1969? No one knows?
Was that when we landed on the moon?
That's the day we landed on the moon, exactly. So this year is the 50th anniversary of Apollo 11. So there's some really, really cool stuff that's happening all over the world that's trying to deal with some of the space race stuff. Including, so Virgin Galactic is doing something that's really cool. They're finally supposed to launch Richard Branson into space himself on that date. I don't know if that's supposed to happen, but that is what they said to the media.
Yeah, I think so. Yeah. Thank you. Who here is interested in pursuing aerospace engineering in college? Hey, Tyler. Oh, awesome. A lot of our lead instructors.
So I will say, like, I'm not an aerospace engineer. I don't have the background in doing rocket science necessarily, and I've learned a little bit about it kind of over the time doing a lot of work with some of these companies. But the cool thing about aerospace now is it's turning into this totally different thing, where you're taking some of the really cool stuff that's coming out of places like Silicon Valley and things that are going on in all these other industries, and you're changing the space industry to kind of work for these really high-tech, intricate designs that are going way past what just NASA was doing. And we're really transforming this industry to a point where you could be any major, you could do really anything, and get your feet wet in the space industry, which I think is really cool, and it's something. I was an electrical engineer in college, and so the stuff that I do is not necessarily like rocket oriented, but I'll talk a little bit about the work that I did, and then the work that I'm going to be doing starting in August. But it really anything that you do, if you're doing manufacturing, mechanical work, electrical work, computer science, even there's a lot of biomedical research going on that's dealing with space. Most of these companies that are doing a lot of this space stuff, and in addition to some of the government entities, will really take any major at this point.
No, let me just move this over here. Oh, wait, okay. Good. Oh my God.
Can you move it a little bit?
I can't, it's off my screen.
Maybe.
What was that? Hey, alright.
Cool. Okay. So, what I think is really cool about space is that it kind of is part of this human exploration drive that I think humans have always had. Ever since like the beginning of history, as far as we know it, humans have always tried to go to the next thing that is the unknown, right? They're crossing the next sea. They're venturing across these countries that they don't know. And I think space has always been that unreachable goal for so many people. And for really humanity as a whole. And so we weren't really able to get there from a human perspective. We were launching, like, people would launch balloons and they kind of invented the rockets in the early 1900s. But the first time that we did something really significant was in the 1950s. So the US sent up a satellite and we finally got to send people up in the 1950s. So it's really cool how far we've come since then. Back in the day, we were really kind of on the verge of the Cold War. Who knows what the Cold War is? What's the Cold War?
Of the war between the Soviet Union and the United States.
Exactly. So it wasn't really, it was called a Cold War because it wasn't an actual war, in the sense that there was no fighting that happened, but it was really just between these two countries to kind of become the top powers of the world. And the huge way that they were trying to outmatch each other was this space race. So what America and Russia both did was they funneled a whole bunch of money into making their space agencies the best and trying to come up with these really, really cool ideas to take us even further into space. It was the thing that no one had ever done before. No one had ever put a man outside of the atmosphere before. And all of a sudden, in the late 1950s and the early 1960s, we had people in space all the time. We were launching all the time. We were trying to do new things. We were launching satellites, seeing how it all worked. And so the people, like people that were your age at the time, were super, super excited about it. Everyone in the entire world was like, wow, we're finally going to space. This is so cool. And so we were putting a whole bunch of money into it. At the time, I believe it was a little bit over 10% of the US's GDP was going straight into NASA. What that means is we had an almost unlimited budget to do whatever we wanted. And in 1961, JFK made an announcement saying within the next 10 years, we're going to go to the moon. Now at the time, that almost sounded to people as if you would say today, in 10 years from now, we're going to time travel. Who would believe that? No one, right? We don't have the technology to do it. It doesn't exist. How in the world could we get to the moon at the time? The technology was not there. And yet, from pure determination of engineers and scientists and the fact that they had a lot of money backing them, they were able to do it 8 years later. So in 1969, on July 20th, we were able to land on the moon. So, this was the Apollo spacecraft that we used to go to the moon. It consisted of a command module where they actually sat. Could fit up to 3 different astronauts. And then they also had a lander that kind of sat inside here. It would come outside, and then it would attach to the nose when it was ready to land. So it was really, really hard. The hard part about this, what would be something that would make launching an entire spacecraft to the moon hard? Yeah. Weight. Weight is a huge thing, right? So we need to build a really, really powerful rocket to get this thing off. So we built something called the Saturn V. And the Saturn V, to this day, is still the most powerful rocket we have ever launched as a human society. And that was launched back in the 60s. We haven't surpassed that yet today. We're about to. We have rockets that have been built. They just haven't actually launched yet. Now this one was the first spacecraft we ever had. So this is the Mercury Capsule. So this is the stuff that, if you guys know John Glenn, and who else was it? Alright, I can't think of names right now. But this is what you would use to like orbit around the Earth. So as you can see, there are these little tiny metal cans that people would just kind of sit in. They just have these little chairs and they just kind of sit there and they can't move at all. And they just orbit around Earth for about an hour or two before coming back down. So that's where we started. We moved to this Apollo thing and they were in here for about 3 to 4 days going to the moon, and they could actually move from one module to another. So they had a lander module they could attach here. They had an airlock where they can move here and actually go back down to the moon. So now, here's the trouble when you're on the moon. Let's say I'm sitting on the moon in that lander, and I want to get home. How am I going to get home if I'm just sitting on the moon? Anybody know? Who can think of some problems with that? Yeah.
You have to have like enough fuel and supplies to relaunch.
So you've got to have enough fuel and supplies to relaunch. So the gravity on the moon isn't quite the gravity on Earth. The gravity on the moon is about 1/6 of the gravity on Earth. So you're still kind of, you're bouncing around, but there definitely is still something pulling you down, and it's hard to get off. It's not impossible. It's a lot easier than Earth, but you still need a really, really good amount of fuel to get you off the surface of the moon. And it's something that's so small compared to like these giant rockets that we built. That's really hard to do, right? So that was a marvel of engineering that we were able to complete on its own. Another one was the fact that if I'm coming off the moon, I need to have my orbit around the moon. I'm just kind of, if you're going around the Earth as a satellite, you kind of just orbit the Earth, and going over to the moon, you got to kind of shoot off and go back to the moon, right? But now you're orbiting around the moon. So this needed to be perfect because this command module was still orbiting the moon at the time that the lander was actually on the moon. So back in the day, there was no automation. There was no software that was able to make all of these things happen at the same time. The amount of power that was in this thing was less than a quarter of the power that's currently in the majority of your phones. So it really was not capable of doing many computations at once. When instead, it was really based on like human ingenuity and intuition and a ton of testing to make sure that we launched the thing, the actual lander off the moon at the exact right second, so that as it was launching and it was coming back up, this module right here would intercept it at the exact point to then connect to it and fly back to Earth. And if we missed that, all the astronauts would have died. There's no way we would have been able to get back. So it was a real marvel that we were able to make this happen. After that happened, we kind of saw that there was a lot more to do in space. And that kind of worked as a really cool way to get people more interested. And the US started building these things. Who knows what this is? Yeah.
Space shuttle.
The space shuttle. So we had 5 space shuttles running. We actually had over 135 of these things launch. Not 135 different ships. We had 135 launches of space shuttles between the 70s and 2011. So we sent a ton of people into space, and we were capable of building a whole bunch of really cool things because of those space shuttles. So we now have the Hubble telescope because of that. We were able to launch that using the space shuttle. And then the really, really big project that required a whole bunch of international collaboration was this thing. Who knows what this is called?
The space station.
The space station?
International.
The International Space Station, exactly. So this thing is still orbiting Earth. It's been kicking since 2000, and because of that, we have had at least 2 people living in space since the year 2000 as the world. There's at least, at any given point between the year 2000 and right now, at least 2 people have been living in space on this thing, which I think is really, really cool. So the other thing that I love about the space industry is that this really shows you that it's one of the few places in the world that we have actual international collaboration between a whole bunch of countries. So when you go and launch that space shuttle that we were talking about, that was really just a US thing, right? The Americans built that, they launched US astronauts, and it became this kind of source of American pride. But this was a huge communication and coordination between the US government, the Russian government, the European governments, a whole bunch of different, Japanese, Canadian, there are all these different modules that were built by all these different countries, and it's still running today and it's still operating, which I think is super, super cool. And we're working with all these different countries. We might kind of have these political differences with them in many different aspects, but in space, we've been working really, really well together, which I think is awesome. So the ISS is still up and running. We've been able to use it to figure out a whole bunch of stuff of how space and humans are able to kind of coincide, and humans can actually live in space. So there are a lot of issues with living in space. Who can think of some issues with living in space? Yeah. Loss of bone mass. That's a huge one, right? So if I'm in space and there's no gravity weighing down on me, my bone mass is actually going to start to deteriorate because the muscles that I normally use to keep myself up are not going to need to be used anymore. So that bone mass starts to really deteriorate. So a way that we can get around that is we can build and test new things using the International Space Station for exercise machines and ways to kind of increase that bone mass after the fact. Who else can think of some other areas where it might be tough to live in space? No one? Just the bone mass? That's all we got? What else do we have on Earth that we don't have in space?
Food.
Food. Food's really tough, right? How do I get food in this little tiny metal tin can, right? Every time I want food, I either have to grow it or I have to send it from Earth. Somebody has to send it up in a rocket to me. And that can get really expensive. So how would I grow food in space? What's the limitation with growing food in space?
Sun.
No sun. Well, there is sun, right? There's sun out there. But harnessing that sunlight is really, really tough because why would it be tough to harness?
You can't open up.
You can't open it. And why can't you open it?
Because then like explode or something.
It explodes? That's what's going to happen? It's just going to big explosion.
Yeah, some type of air pressure thing.
Air pressure, that's a huge thing, right? So what happens when you're in the middle of a vacuum? If you just go out into space and you're just kind of chilling there, what's going to happen? Yeah.
It's really, the blood boils.
So blood can boil for multiple reasons. So the main part of it is that we're in a vacuum, right? There's no air, and that means that there's no pressure. And that your body is used to living at a certain pressure that kind of keeps everything together. And without that pressure, everything kind of expands a little bit. Blood starts to boil, and you can't breathe. There's no air to breathe, right? So we need to keep an ambient pressure inside this thing. And we also need to keep enough air for humans to live there. As I said, we've had humans living on this thing since the year 2000. So there's a lot of problems that we need to solve, and it takes a lot of engineers to figure out all of these problems and how we can solve them. Now, since then, in 2011, we actually retired the space shuttle program. So a lot of the people that were bringing up there were on these space shuttles. We had a couple of accidents that were really kind of bad for morale and bad from a monetary perspective as well. So in 1986, the Challenger, which was one of the space shuttles, exploded because there was a O-ring, there was a gasket that was kind of keeping the air in on one of those really, really big tanks that were back here. Back on that big orange thing. And the problem was that they launched out of Florida. And so they didn't do a lot of testing, and so this is why testing is so important for a lot of engineers. They didn't do a whole bunch of testing for these O-rings in certain temperatures, because they're like, we're launching out of Florida. When is it going to be cold in Florida? Well, it turns out on the day it launched, it was actually below freezing. And they had no idea how it was going to react. They launched it anyway. There's a lot of theory and speculation on certain things I'm not going to get into, but the point is they didn't do a lot of testing for it. The O-ring did not work, and the gasket actually broke, and a lot of gas, there was a gas leak, and the entire thing exploded. So that was one really big setback. The other one was in 2002. The Columbia exploded because on the way up, a little piece fell off and blew a hole straight through the space shuttle's wing that they didn't even realize until they were all the way on back coming in for their landing. And at that point, it actually exploded and killed all the astronauts. So those were things that really had these huge setbacks for our space program, and the U.S. Congress canceled the space shuttle program. So since 2011, we have not launched any people into space from the U.S. So how have we been doing it? We've still been launching people. We've been launching about 4 times a year, but we've been launching on these things. So anybody know what this is called? So this is the Soyuz rocket. So this is the rocket that the Russians have been using since the late 80s. This is the only thing that we've been launching people on into space since 2011. So this is the actual capsule itself where the people are. It's pretty much used as a transportation unit from the ground up to the International Space Station. So we've been launching about 4 times a year. But the cool thing is about this year specifically, as I said, 2019 is a really cool year for space, because these guys are finally going to hopefully get launched this year. So what NASA decided to do with the cancellation of the space shuttle program, they said, well, we still want to launch people from space. So what we're going to do is we're going to start paying private companies to do it for us. So it's still government-sponsored programs. Citizens aren't paying. It's still the actual NASA's program, but instead of manufacturing it themselves, they're going to say, all right, we know that other companies can do this because they have the money to do it. We're going to give them grants to go figure it out, and they're going to be more innovative than we can. So they gave the grants to Boeing and Spacex. And at this point, both of these things are done. Spacex actually launched this thing back in February, and it worked beautifully. So they're both fully automated. They're brand new technologies that have never been used in space before. So this one's called the Dragon Crew. Hopefully it's supposed to launch at the end of August with people. I think they may have pushed the timeline on that. Timelines in the space industry kind of get pushed a lot. And then this one is the Boeing CST-100. So the cool thing is that I'm going to start working for Boeing in August. And this is run out of the same office that I'm going to be working at. So I'm potentially going to be working on that team, which would be really, really cool. So the cool thing about these is they can carry more people. They're fully automated, and there's a lot more that they can do with it that doesn't require the old technology that we used back in the 80s for the Soyuz. So that's something that's really cool right now that's happening. But beyond that, there's a lot of stuff going on in this commercialization sector. Who knows what commercialization means? Anybody think that they have any ideas? Yeah.
Shifting of an industry more to like a privatized.
You got it. Shifting from an industry to more of a privatized way. So while we were talking about this space race, really it was kind of the US versus the Russians. It was really just these government space agencies that were doing all the work. Back in like the mid-2000s, when NASA kind of started taking a back seat and it looked like they were going to cancel their space shuttle program, and they really were like, I don't know what we're going to do anymore, we're going to run the ISS, but we're not doing much exploration, and there really isn't that much going on, there were a lot of people who were like, wow, I was so inspired by the fact that someone landed on the moon in the late 60s, and we haven't really done anything that impressive since. We have way more technology now. Why can't we use all this technology that we have in all these other areas and bring it into the space industry? The problem with NASA doing it is that they have to go through Congress, and they have to go through all these government agencies that don't totally understand the technology. And because they're not as hyped up as they used to be in the 60s, it's really hard for NASA to just be like, all right, we're going to do this. So instead, you have a whole bunch of billionaires and a whole bunch of really rich people that are saying, I like these ideas. I think that you have a great idea to kind of implement this technology and bring it into the space industry. So I'm going to fund you instead of the government funding you. And that's how we came up with a whole bunch of these really, really cool companies that are happening now, like Spacex and Virgin Galactic and Blue Origin. So those are the 3 I'm going to be talking about today. The first one I'll speak about is the one that I work for. So this is Virgin Galactic. Their main focus right now is getting random people as a paying ticket into space. So right now, you could buy a flight on this space plane for $250,000, and it will take you into space for 10 minutes. They have not launched any paying passengers yet. However, they did launch 4 people as astronauts over the last couple months, and they are supposed to launch Richard Branson on the 50th anniversary of Apollo 11. So we'll see how that goes. This is what they built. This thing is actually fully operational in New Mexico right now. So this is their spaceport. It's supposed to operate as an airport where you can go and just get a really quick flight into space. You wouldn't pay for it there. You'd pay for it obviously well in advance, and they kind of take care of you along beyond that. But it's meant to be very futuristic. It's really cool. So I'll show you a video of how this works. It's a really, really interesting design. So the spaceship actually is attached to the bottom of an airplane. When it drops the spaceship and it fires, it actually launches from the air. We call this an air launch. After it launches, it goes from a horizontal position and kind of does this thing that we call a gamma curve. And it goes up like this. So you can see the spaceship going up all the way like that. So it goes out of the atmosphere that direction. And then when it gets to the top, so this gets to, when it will be at full thrust, it will get right past the thing that we call the Kármán line. So the Kármán line is what kind of the international definition of where space is. So it's about 80 miles up, not quite to, so the International Space Station is about 250 miles away, and the moon is about 250,000 miles away. So it's a long way to go to the moon, a long way to go to the International Space Station, but it really gives you this full experience of being weightless. You get to see kind of the black of space, and you can truly see the curvature of the Earth and kind of a whole bunch of stuff around it. So, this thing is kind of looks like a plane, right? You got wings on the side. It doesn't look like your typical rocket. So as you see, this thing will start to move it. We have these things on the back called feathers. So who knows what a shuttlecock is? What's a shuttlecock?
The thing that you use to play badminton.
To play badminton, exactly. So if you take a shuttlecock and you throw it, how is it going to fall?
Down.
Always, right? No matter how you throw it, no matter the orientation you throw it in, no matter the speed, the direction, no matter what, it's always going to go down. So, the guy who designed the ship, his name was Burt Rutan. He did the exact same thing with this. He did the exact same thing with this spaceship, where these things in the back work as feathers on a shuttlecock, and they are moving upwards, so that from a pure physics perspective, it is impossible for this ship to fall in any other orientation than purely parallel to the ground. So they can totally control the way that they actually fall back into Earth. Which is really cool. So then when it gets back down to the 50,000 feet mark, which is where the plane actually launched the spaceship from, those feathers come right back down and work just as wings, and then the thing glides right back onto a runway just like a normal plane would. So you get that full experience of kind of going into space and getting that whole thing without actually needing to strap yourselves to the top of a rocket. It's a nice, like, leisurely kind of flight, and you get to experience the zero-G weightlessness. So it's, as far as the pricing goes, I realize that $250,000 is a lot of money. It's not something that the normal person is going to be able to pay for this thing, especially because it's only about a 10-minute flight in space itself. That being said, if you actually go back and look at a normal commercial plane, when commercial planes first launched, if you were back in, I believe it was the 40s, if you wanted to buy a ticket on a commercial plane, it costs roughly, adjusted for inflation, $250,000. So the actual flight, like the money that they are using now, the goal is that within the next couple decades, this thing's going to get down to the point where the normal consumer can kind of do this as a vacation. Next one is Blue Origin. Who knows who this guy is? Jeff Bezos. So this is his company instead. So they actually are the direct competitors of Virgin Galactic. So they're doing something very, very similar. The difference that they have is they actually are strapping you to the top of a rocket. So you kind of get that full rocket experience that all of these astronauts back in the 70s and 80s still got. So the capsule that you sit in, the thing that's right behind Jeff Bezos, is fully automated. There's no pilots in it whatsoever. So a Virgin Galactic's thing is fully manual. There is no automation in it whatsoever, and you have 2 pilots in it at all times. So this one's fully automated. When you get to a certain position, when you get up to almost the Kármán line, the capsule actually pops right off of the rocket, and the rocket comes right back down. So I'll show you what that looks like with the rocket landing.
It's time to go to space. Let's get ready for run, Shepard.
So here's something that's really interesting. So this rocket's actually super, super light. So if you guys look at the plume, we call that the flame, the plume. it looks really different than a lot of the space things that you've seen launched before, I'm assuming, right? A lot of those have those really, really big gas, like bubbles and whatever. So this is very, very different. It uses a brand new kind of engine technology that's able to make it a lot lighter, in addition to the fact that the rocket itself is a lot lighter. So when it comes back down, it adjusts itself using a whole bunch of these fins on the side to kind of stabilize itself, and then when it gets closer to the ground, it relights its rocket so that it can land really, really nicely on Earth. So I know, so SpaceX is really, really good at doing stuff like this. Blue Origin was actually the first company to ever do that, to launch a rocket and then have it land vertically like that. So after that, as a passenger, you're kind of sitting in this capsule, and you come right back down to Earth after about 10 minutes and land in the middle of the desert, about a mile from where you launched. So it's a pretty different experience than the Virgin Galactic flight. You're kind of getting a different feeling of kind of launching on a rocket instead of launching from a plane, and you land in a very different way. But it really is the same, and it's also roughly about $250,000. Blue Origin is also doing a whole bunch of other stuff. So unlike Virgin Galactic, they're kind of in a whole bunch of different industries. So they're also in the satellite launching industry. So this one is supposed to launch like small satellites that you could go pay like a couple $1,000s to go launch their satellite from Blue Origin. And they also just unveiled this lunar lander. So their goal is to put people on the moon, so paying customers on the moon by 2024. I don't know if that's going to happen, but that is their goal. And then the next one is SpaceX. So SpaceX is kind of in a whole bunch of different industries in the space field. They're not direct competitors of Blue Origin and Virgin in the sense that they don't have the market where you can just pay them to go to space. They have a whole bunch of other things that they're doing. So they've really perfected this thing of kind of landing these rockets on a dime, where anybody know what this is called? Falcon Heavy, you got it. So Falcon Heavy is going to be one of the more powerful rockets we have ever launched as a human society. So this thing is capable of carrying so much weight, and it has 3 rocket boosters. So when it launches, this thing is actually capable of now, it's the first one ever that can actually take all 3 rocket boosters and bring them right back down to be fully reused. So they land 2 of them pretty close to where they launched, because when they detach, they're in a position where they're not actually too far out. The difference between this and what Blue Origin was doing, Blue Origin and Virgin do something that we call suborbital flights. What that means is you actually haven't reached the area of orbital yet. You're below it to the point where you're not actually orbiting the Earth. SpaceX, on the other hand, is launching satellites and things that are going to be orbiting the Earth, potentially even going further than the orbit of the Earth. So if you go in an orbit of the Earth, what that means is when you launch, you have to kind of follow this curvature. And when you come back to Earth, are you going to be in the same position that you were when you launched? No. Right? It's going to be really, really hard to take that position when you kind of fall back to the atmosphere and bring it right back. So what they do with their 2 rockets that kind of detach before they actually get, so like the 2 that are going to land here, they detach well before that orbital range. But the one that is still on the actual rocket and the payload launch, instead they land on these barges in the middle of the sea. So the next part of this video will show you what that looks like. So instead of having the rocket kind of maneuver to come all the way back to where it launched, they'll actually say, okay, that's fine, we'll just let it go all the way out there to where it kind of fell normally. We'll send a drone ship, so this kind of barge right here, we're going to send that out into the middle of the ocean to catch it. So this thing will then land on the ocean. Because of the way the wireless communication works, they actually can't get communication when it's really, really close, because there's too much vibration and stuff. But you should be able to see it when it's fully landed. So it lands just like that. And we can recapture all of those rockets. So SpaceX has gotten really, really good at doing this all at once. In addition, they're doing a whole bunch of other cool stuff. So in the future, they're looking to really, this is kind of their main goal. It's kind of colonization of both Mars and the Moon. So using this thing. So they call this the Starship. The Starship is going to be capable of carrying 120 people at once, which is pretty insane for any of the standards we've ever had for spaceflight. Their first launch is supposed to be in 2021, carrying about 3 people. It's going to go, the goal is to bring there's somebody who paid $30 million to go to the Moon on that thing. Ooh. Let's change. So somebody's already paid to go to the Moon. Their goal is also to get there by 2024. And then something that I think is really cool, I've been working with satellites as well for some of my stuff. So this is something that they call Starlink. Anybody hear this in the news the last couple of days? Yeah, you know what it is?
It's a network of satellites.
A network of satellites. So what's so cool about a network of satellites?
I think maybe internet. I'm not sure.
Internet. Yes.
Is it for like the 5G network or?
Not quite. It's actually a different technology than the 5G network. So the cool thing about this, so they just launched 60 satellites at once. It was actually the largest simultaneous launch of payloads at once ever. No one has done that before. But the coolest thing about this, I think, is that they're eventually going to launch, their goal is to have 15,000 satellites all orbiting in this crazy network, where all of the satellites are actually talking to each other and coming up with a way to kind of communicate with each other and provide internet anywhere in the world. Now, it does two things. One, it provides internet to a whole bunch of places in the world that currently don't have internet, which I think is really, really awesome. There are a ton of studies that have shown how that can kind of improve societies. But the other thing that's also really cool is that it is not possible to achieve fast enough internet on Earth that you can achieve in space. Because we use fiber optic cables on Earth, and when you send light through a fiber optic cable, it actually it doesn't travel as fast as it does in a vacuum. So when we have light traveling in space instead, we can actually travel 40% faster than it would in the glass of a fiber optic cable, and then we can send data at a 40% faster rate using internet satellites instead of fiber optic cables, which I think is really cool. So they're working on that. And then this is something that is hopefully going to be happening in the next 5 years. So there's a company called Axiom, which has pledged to buy the International Space Station from NASA. So NASA's contract for the International Space Station runs out in 2024. Right now, it kind of looks like they're going to be extending it into 2028. But after that, the plan was to just have the entire International Space Station fall back down to Earth. Now, we can control its fall to make sure it doesn't hurt anybody. That's not a big deal. But the point is it would no longer be operational. So Axiom, who's run by a whole bunch of guys that used to work for NASA and kind of have been doing a lot of this tech stuff, said, you know what we're going to do? We're going to buy the International Space Station from you, and we'll run it instead. We're going to separate a couple modules that aren't going to be working for us, and we're going to add a couple of our own, but we're going to run it like a space hotel. So we can have paying customers come up and live there for us and just kind of have a vacation, in addition to doing a whole bunch of other really, really interesting things. So you also have other companies like Bigelow. So Bigelow just invented these really cool space stations that can actually inflate. So you send it up and they're super light when you send them up, and then when they inflate you have a full livable space that you can use and work in. So those should be launching in the next 2 years. Axiom is launching their first crew to the International Space Station in the next 2 years. And the really, really interesting part about what Axiom is doing, it provides brand new opportunities to do things that we've never been able to do before. So one of them is in research. Right now, if you wanted to do research on Earth, there are two things that are really, really tough to do to get control variables. One is gravity. Who can think of a way that we can replicate zero gravity on Earth? Free fall. That's really the only way we got. We don't really have another way to do it. So right now we have this thing called the vomit column, or the parabolic flight. What that is you get in a plane, and the plane goes up really, really high, and all of a sudden it just stops, and you free fall for about 30 seconds. And then 30 seconds later it catches you again and goes right back up. And so during that 30-second period, you're in free fall and you're feeling the zero gravity, right? The problem with that is you can only really do a 30-second experiment. You're really, really limited from a time perspective. The other thing that's really, really hard to replicate is a vacuum. It's really intricate for us to create a pure vacuum on Earth. Luckily, space is almost a pure vacuum in itself. So we can use those things to do from a scientific experiment perspective, to do a lot of experiments that we could never do before. And Axiom is providing that opportunity for humans. The second is manufacturing. Now, manufacturing is not something that people would say, oh, manufacturing in space is kind of weird. Why would you go up to space to manufacture something? Well, the really interesting thing about it is if you look at certain metal alloys, and you look at fiber optic cables, and you look at satellites, it's actually so much easier to develop them in environments with zero gravity and vacuums that it can be insanely cheaper. So there has been a study about fiber optic cable manufacturing, specifically. If you were to take into consideration the cost of launching, maintaining, and bringing back the supplies and materials to both build the actual factory itself and the fiber optic cables in space, it would still be 30% cheaper than doing it on Earth. Because you have a fully controlled environment where there's no gravity, and you can do it in a vacuum where you don't have to worry about all the cables kind of bunching up in different ways. In addition, has anybody ever seen those like bunny suits that people wear in like factories and like laboratories? So those are like the really like, you kind of look like a marshmallow, you're walking around, and you can't really talk, and you can't do anything. So what this allows us to do is we have a control environment where there's no static energy and there's no random particulates in the air, and we just have a lot more control. So there's a lot of cool stuff happening, and hopefully it's going to be happening in the next 5 years. So, yeah. Any questions?
Karan?
No.
All right, thank you, Asher, for a great talk on space exploration. He's around for extra questions. I'm sure you guys have a lot.